Hi, I'm Doug Day. I'd just like to share with you a quick demo on our software package for loading up, concatenating, and plotting data from the TSI SMPS, Scanning Mobility Particle Sizer. So this is the AIM software, which is where you record the data on the instrument, and then you can view it. So just your END log DP, size distributions. And I can choose all the files I want to export into a text file. You can go to export to file, choose rows, DND log DP, click OK. Then I need to give it a file name. Then I would hit save, and then it would export it to speed things along. I've done that already. Here are a couple text files. You can do as many as you want. These are two different experiments, 2 days back to back. And need to be named specifically, which is described in the IPF header, among other instructions. And we can open up the Igor IPF. And we have the code here, as well as a bunch of instructions at the top of the IPF. Should be a drop-down menu called SMPS. Can pull up the panel. Need to choose the AIM version, which I downloaded the data or exported the text files from. And I can choose the bins per decade, and then I can load and concatenate, give it a folder name, which will just be an Igor. Hit OK. Choose the folder where the text files are, and we'll load those up. The first file, the second file shown up here, and then it's done. And I know this needs to be regridded because those two different experiments had different size particle range, so then it can fit it into the same rectangular matrix. And I can go here and just plot the number distributions, your classic DND log DP, those time image plot. This was an ozonylysis of limonene experiment in the chamber, a lot of new particle formation, and then the particles grew. You can also plot up the integrated time series of the number, just put below, and you can see a lot of new particle formation and then slow loss in the chamber, similar with the other experiment here. Going back to the panel, you can also plot up the volume distributions, dV log DP. You can see that shows up at larger sizes due to it being in volume space. And then I can also do the integrated volume, which times density would just be the mass concentration in micrograms per meter cube. A lot more particle mass here due to the larger sizes in that second experiment. Another thing it calculates is the condensational sink rate coefficient. These are the parameters that you input. They could be scalars or time-dependent waves, depending on which you choose. Then I can plot up that integrated condensational sink. Shows up here in just units of per second. So the inverse of that would be just the time scale of molecules condensing onto the present particle surface area here. Another handy feature, we can just take an average time period and plot the size distribution with a marquee here, and I can add another one. Let's go over here a little bit later, bigger particles here, and then that adds to the plot, and I can keep adding. You can do this for the number distribution, volume, surface area, or even the condensational sink. And there are a few other features here. You can smooth the data. You can change the max percentile for the color. So the color contrast, if it becomes too saturated, you can see over here. For the volume, it's you can barely see it, so you can change that, replot it, and then you have the size range as well for the integrated plots if you want to integrate for just a specific size range. So hopefully you find this useful. We've distributed this, shared it with a number of users in the US and across the country. That's all I have. Thank you.